Alright, so begins another draft physics video presentation. Still just presenting, I think. Not really producing, but we'll see. Improved background, perhaps. Try some different things. Anyway, so I was thinking I would first maybe talk to the dissidents out there. I'm sure there's a few that watch my videos. And how we can organize and develop a way of popularizing, making it more possible to speak to more people and to do so with some authority by forcing conventional physics to meet some portion of the argument. Now, there's little expectation that they will read any of your papers or pay much attention to your videos and argue why your physics is wrong, because they just couldn't care less to try. Too much time consuming. I just read an article by Sabine Hoffenfesser or whatever, ragging on the email she gets because people send her proposals, arguments even. And she finds it irritating and all ignorable. So that's basically her standard. I just ignore everything. And so if you're not in my stream of information, what I consider to be legitimate sources, you're not going to get heard. And that's the way it is. And but she does offer lessons in physics at a price. And I'll be willing to pay the price. So I've inquired of her whether I can make those lessons public, because frankly, I can ask questions, and that's a doable thing. And the whole thing would be you have to play on their field. So my argument to the dissidents is that we should maybe somebody should put a Patreon page up or whatever, a GoFundMe, just to raise money to seduce named physicists to be subjected to our questions. And we'll have to keep our questions in their ballpark. That is, question them on the integrity of their own physics. So question them on what they think of the Eddington experiment, for example. What they think of the fact that it's never been repeated with a satellite. Even though we have thousands of them up there, not a single one's ever done the experiment, as far as we know. The lens is the wrong shape, the gravity lens. The two-slit experiment pattern in light and photons is not what the mathematics predicts. The beam splitter idea, when you're using a half-silvered mirror, what's the concept here? How does it create two equal beams? When, if you know anything about light diffraction, you know that the one beam is being diffracted through the whole length of the interferometer and the other beam isn't. Huge difference in the two beams. Those kind of questions. And then on relativity, attack them on where does the energy come from? What do you mean there's no absolute speed? So every speed is some sort of relative speed and there's no such thing as a real speed in the universe? Or does photons have the real speed? Is that the catch? I mean, what exactly are you saying? Nothing can move the same direction that a photon's moving at a fast speed? It's always somehow relative. Well, if it's relative to a photon, isn't it an absolute speed then? Those kind of questions. Just inquire of them. Just attack essentially the feeble and weak foundation for their whole physics. All the jargon they use, the moving charges, and all of a sudden moving charges are dipoles. Where's the evidence that an electron is a dipole? Do you have a single experiment demonstrating an electron doing something dipolar? All that kind of stuff. Because their foundation is garbage, and it should be shown for what it is, a story. They're just telling a story, and it's a story that has no more real evidence than a religious story. And they should be put on the spot, and that's what we can do. The expectation that they're going to, like I said, pay any attention to our counter arguments, our counter mathematics or something like that is, unlikely. And as a collective, at least we could agree that questions need to be asked. So we could make a list of questions. People who donate the money can essentially pay per particular question. So yes, maybe someone will be flat earth questions or something. And then anyone who submits a question can obviously anticipate a bullshit answer and provide follow-up questions. And then just select somebody to do the interviewing of the physicist or whatever, maybe a couple of people. And they would just inquire of these know-it-alls, and that's what they claim. They claim they know the truth. They claim they have the right answers, and their answers are garbage. And there's absolutely no evidence that they're doing any of this free thinking thing they all support. I mean, there's lots of Einstein quotes, about the dangers of assumptions and the dangers of writing it in stone. And that's all they've done, and it's all Einstein did. They're guilty of the crimes they preach against. We certainly could attack their scientific method, and that these experiments aren't repeated. They don't have any, like LIGO just tells you, we're measuring half the distance of a proton. Yet they don't have a single example of their device measuring anything, let alone half the distance of a proton. And then, just interrogate them on these facts. I mean, ask the physicist, do you know that the beam of light is bouncing back and forth between the mirrors 1,600 times? Well, what do you think of that? I mean, if every reflection off the mirror might be anywhere from 1 to 20 atoms deep, do you think atoms are smaller than protons? I mean, if you can't even predict how far into the mirror the light goes before it reflects, how can you be measuring half the distance of a proton with that device? Is there any reasonableness to it? No, it's not a reasonable. It's not a reasonable statement that my ruler, is in mile scales, and I'm going to measure half the distance of a proton with it. I don't think you are. So anyway, that kind of thing. It obviously has to be done in a polite enough manner, but the fact is we're paying them. So, and we'll just take whoever the highest profile physicist wins. In terms of we'll put up a number for an hour of their time, and see what we get, see who we can seduce to carry the banner for their physics. And of course, it would be open to, if people want to pay to have a flat earth dopey question asked, that'd be okay. But, they're obviously so debunkable by just pointing out you have this ludicrous theory that every single person that's worked in any kind of satellite technology over the last 70 years is a liar. Yeah, you're crazy. We're done. That's too silly. Just throwing it out there. That's probably one way, at least, that we can work together for the same purpose, which is to have science interrogated. If we can't gain enough respect to have our physics scrutinized in some sort of rational way. The only dissident, the only way they ever scrutinize is just to insult everybody. Just to call everybody a tinfoil hatter, throw them in the same category, and say they have the same integrity. And so they use the worst case examples and just say everybody's a flat earther. Professor Lewin was guilty of this. I mean, he called the guy with an electrical engineering degree who was making a perfectly rational argument, a flat earther, because he disagreed with him. And that's the bullshit. And somebody's got to call them on that bullshit, but there's nobody in the physics world that's willing to do that. You could argue to some extent that Sabine Hassenpfeffer is doing that a little bit, but I think she has her own sacred territory. I mean, she doesn't mind picking at the stuff that has nothing to do with her, kitchen. But I think if you got into her kitchen, she'd just be just as defensive and just as, unwilling to take the heat that she deserves as the rest of them for her little sacred beliefs. So, just throwing it out there. So we'll do some comments. Call it a day. I gotta brighten that up, don't I? Yeah, just go this way. Okay. All right. Very underrated channel. Thank you, but who knows? Man, what's up with your email? Yeah, well, look, you have my Skype, so it really shouldn't be that big a deal. But yes, to whom it may concern. Look, I was getting no emails anyway on physics. The DraftPhysics.com domain, I had to move it because GoDaddy was insanely expensive. And the other place that hosts it doesn't forward the email, which is kind of bogus. So that domain doesn't accept emails at this time. If you use the website, the form still works, so you can do it through the website. But anyway, so I've changed the email address provided in the description. So the new videos will have an improved email address, when that does work. But yeah, sorry. This part of navigating the capitalist shyster system. It won't get delivered for some shit. Yeah, well, obviously yes, there's some reason it happens. That's the world of technology. I guess you're not that into it to know that yes, there's lots of bullshit going on in the technology world, just like any other world, full of shysters and crooks. I'd love to have another chat with you. Yeah, well, I don't know. What are you bringing to the table? I don't know. But anyway, fine. But like I said, you're just, if you want to have a conversation or a chat with me, we'd have to do it through Skype anyway, so you could send the message through Skype. Although I don't check my Skype that often, but regardless. Anyway, so I guess I'll remove that just because it's a little bit too personal a thing. All right, so zoology. Anyway, yeah, I did the experiment with deflecting electron beam with a magnet in a vacuum tube with fluorescent material in it. Okay, so a Crookes tube. Cathode ray kind of concept. Pretty standard, the idea of creating an electron beam. Now the question when you're creating electron beams is it's degrading the cathode. The cathode's the one shooting the stuff out. And over time it degrades. It's sort of like, it's not that dissimilar to electrolysis, where you're putting metal from one thing onto the surface of another thing. There is some of that going on. So, strictly speaking, whether it's all electrons in the beam is sort of an open question. I would argue that you're also shooting some ions in the beam. But, for the sake of argument, well, see, there's really no for sake of the argument because, there's, little evidence, demonstrating any pure, truth here. It all depends on how you're looking at the device, even the device itself and how it's engineered. It has the anode, and then it has a little slit in it, and then it has a fluorescent material that's put at an angle to the beam. Lots of different little things that to the eye you don't know, you don't realize how exactly the path has been created. But anyway, let's play along. It turns out it did experience the Lorentz force. Well, says you. Although, depending on the strength of the magnet and how far the magnet is from the tube, it appears the beam is bending straight away or to the magnet when you bring it near it. So you're saying two different things. You're saying, yes, it does the up thing, and then you're saying, no, it moves towards the magnet. So, it's left kind of open what you're saying. Now, I just did some Google searches and this and that, and I saw an animation, which is sort of irritating that now they animate things like this instead of actually show you the experiment. And they showed it both ways. They showed taking a regular north end of a magnet and bringing it towards the tube, and the beam bent right into the north end of the magnet. And then they show a bar, a horseshoe magnet, with a north and a south end, and then they show going up with the Lorentz force. I mean, I don't think you can have it both ways, frankly. Okay, it turns out I did the. Okay, although we already did that. Bending straight away or to the magnet when you bring it near it. But this is only because there are components of the magnetic field. So, I mean, you're going to assert things about what the fields are doing and what's in the fields and all this stuff. And again, I'm going to argue that you don't have hard evidence for any of those assertions. So you keep saying, you can tell me that, the standard model of the atom is correct and electrons move, around nucleuses and all this stuff. And I'm going to say, well, you don't have any evidence of that. All right, of the bar magnet that are, but this is only because there are components of the magnetic field. So again, a component magnetic field, it either is or isn't a magnet. Sorry, it's really not something that components. It's like saying components of the sun's light. There's no components. It's all the same stuff going everywhere. Of the bar magnet that are perpendicular to the direction of the magnet itself is in. The direction the magnet itself is in. So I'm supposed to know what that all means. But this is only because there are components of the magnetic field of the bar magnet that are perpendicular to the direction of the magnet itself is in. Says you. So the electron beam is still experiencing the Lorentz force. Says you. I would argue that if your magnet is radiating energy like a sun in all directions, so some of the angles, like any round thing, is going to radiate in all directions. So when you're bringing the magnet towards something, you're moving it towards something, it's not just radiating straight lines. It's radiating lines up and radiating lines down. So if you're bringing it below the electron beam, there's going to be some tendency to move up because you're getting hit by those beams going this way. You're not going to get hit when the one's going this way. You're going to get hit with the ones going this way underneath the beam. So it'll push it up a little, right? And likewise, if you do it above the beam, you might push it down a little. So, there's a lot of tricks to it. So it has to be done kind of carefully, and you have to do the experiment a few different ways to really tease out the truth about actually what's moving. I'd say the clear truth is that when they do the experiment, it's clearly not the same Lorentz force that shoots the wire out of the magnet. So when you put voltage through a wire, it's not as clear cut. All right. So the electron beam is still experiencing the Lorentz force, but it's coming from those perpendicular components. Again, you're just making assertions. What do you want me to argue? I'm saying the Lorentz force is something that happens to dipoles. It happens to ions. It's not going to happen to electrons by themselves. They have to be in association with an atom. They have to be polarized to know even what up is as a direction to move. A free electron is going to do what electrons do because it's one thing. It's a negative particle. It's going to move towards the positive end, and it's going to move away from the negative end, the north side. It's going to move away from the north end of a magnet. It's going to move towards the south end of a magnet. That's what electrons do. And so if you have some other theory about why they should do some Lorentz thing on their own, I'm saying that doesn't happen. And I've pointed it out through other experiments where they say, like accelerators and the rest of it, where they're really accelerating ions. They're not accelerating electrons. And then they use Stern-Gerlach, where they talk about what electrons do, when those are clearly silver ions. All right. The field of a small bar magnet is not going to be uniform, yet it is. Compared to the length of the Crookes tube. It's going to be uniform in the sense that it's going to be a fan, okay, and the longer the distances, the less the force. So it's going to be strongest where the straight lines are and a little bit weaker where they have to go far further away, just like the sun. Crookes tube. And if you look closer, you'll notice that only the part of the beam that is far from the magnet is deflecting directly towards away the direction of the magnet itself is pointing. So he's arguing that the forward portion of the beam, so I have the magnet here, the beam shooting across, he's arguing that this portion is doing this and this, while this portion of the beam is doing this and this, up and down. And maybe. I'm still going to argue that this up and down thing is the thing you're not going to demonstrate clearly. All right. Until you use something like electric current, right? You know, with plates. See, the other thing they do is they put plates in so they can put a charge across the beam and move the beam up and down. And the problem is then when you bring a magnet in, you're going to magnetize the plates. Okay, so they're going to become little magnets, and they're going to affect the beam. So, you know, this is where you got to do experiments a little bit carefully, and people just don't pay any attention to that. I mean, even the thing you have the fluorescent material on, you have to make sure it's non-metallic. All right. But the part of the beam directly in front of the magnet doesn't seem to move because it's moving in the opposite plane against it, away from the fluorescent material. So, yeah, I'm sorry, you know, you sort of got to draw a picture. I mean, it's very unfortunate that you did this experiment and you don't have any kind of video recording capacity, like a webcam or anything at all. It just seems like the kind of thing you should have recorded. All right, anyway. When I did the experiment, you could notice this when the magnet was facing only south-north. That's so using a bar magnet, you're only sticking one end of the magnet near the tube. Can't remember which one, because the beam along the fluorescent material would get less intense. Well, then it's moving away from it, obviously, indicating it is moving perpendicularly. Says you. Okay. While the part of the beam further away would move in the opposite direction. Whatever. The beam farther away, the opposite direction. Again, it just doesn't make any sense. The beam moves this way and then it moved that way, or it moved this way and then it also moved that way. Can't really do that. Directly towards, away from the magnet. Yeah, I know. Well, you just said one part's moving towards, and you're saying another part's moving the opposite way. Only because it's experienced the Lorentz force from the perpendicular components of the magnetic field. So again, you're saying there's perpendicular components in the magnetic field, and there really aren't. I mean, the best there can be is this stuff. There can't be perpendicular. You know. I mean, you know, perpendicular components, I guess you're just saying this, the idea that the magnet is going to produce field energy in this direction and in that direction. It's a cone of energy, you know, cones of energy. And some of those are going up, and some of those are going forward, and some of those are going backward. But the point is it's all moving this way, and that's going to be the tendency, is to push the electron that way. All the energy, no matter what direction it's coming from, is saying one thing to the electron: go away or move towards me. All right, otherwise, let's see, only because it's experiencing Lorentz force from the perpendicular components of the magnetic field. Otherwise, if you point the magnet from the left side of the tube, you see the beam move up, down. The left side should matter, the right side should matter. That shouldn't make any difference. So, yeah, it's just unfortunate you couldn't take any pictures, you couldn't take any video. It's not very helpful. Maybe you could find a video on YouTube demonstrating what you're saying. Like I said, all the ones I've seen are quite subject to interpretation. They're not very clear. Yeah. So, yeah, I guess, no. Maybe that's enough. Let's see if there's anything new. You know, for my part, it is, you know, I have attempted to put together questions in the past, but, you know, I'm seriously thinking of you know, where I can pay for it, I'll pay for a physicist's time. and to ask them questions, right? You can only ask us questions about physics, and we, but the important questions are, do you know that, like most of the videos on that are available on YouTube describing the two-slit experiment say that there were detector experiments done, and do you have any evidence that any of those were ever done? Just inquire of them what their knowledge is on the subject. But that's all you can do. All right. So I think that's it. Let's see if there's anything new in the. It's just terrible. I mean, there's just nothing. I got to find something to subscribe to. No one says anything about physics here. This is just all such crap. It's just pitiful. So anyway, let's see what the new Sean Carroll video is. Ruben Harris. Robin. Oh dear. Psychedelics. Oh, isn't that great? What a great subject. Yeah. I mean, the psychedelic people have given us so much. They've cured cancer so many times. Yeah. Christ. It's just so bad. Idiocracy. It's all over the place. Terribly depressing. Alright, so that's it. We're done. Hopeless. Tragic. Pitiful. So, till the next time. And